last video for chapter 7. So section 7 of chapter 7 is looking at equations involving inverse trig functions. So what that means is we're going to solve equations kind of like 7.6, but um, we're going to use inverse in order to do it. So here's an example. Y equals 3 times cosine of 2x. And so we're taking cosine of 2x and then times it by 3. So we're trying to figure out what is this x, which is on an interval from 0 to 2 pi is where we're going to find our answer. But we're solving for an angle, right? So here we're going to use inverse in order to solve for that angle. Another thing we're going to do in 7.7 is actually solve inverse problems. So if this was like a cosine inverse, so cosine inverse and solving that type of equation. So that's what 7.7 is about. So let's go ahead and solve this. So basically we want to get cosine first by itself. So cosine of this by itself. So that means we're going to have to divide by 3. So we have y over 3 equals cosine of 2x. Okay, and then once that's by itself, then we can go ahead and take the inverse, right? So the inverse of cosine is cosine inverse or arc cosine. Remember, arc cosine is the same thing as cosine inverse. So don't be scared when you see that. Okay, so I want to take the inverse. So that means my x's and y are going to switch places. This is going to switch places with this. So cosine inverse of my answer, y over 3, is equal to 2 over x. Is equal to not 2 over x, 2x. And then I can go ahead and solve for x, divide by 2. Divide by 2 is the same thing as timesing by 1/2, right? So here's my answer. X is equal to, my angle is equal to 1/2 cosine inverse of y over 3. So here's my basic answer. So it all depends on what y is, right? And so because of our function is 3 cosine of 2x, that means the graph of that, right? It's cosine, but it's the period length is just pi. So it's going to look something right like this, but it's only going to go to pi. And I'm stretching it from 3 down to -3. And I'm restricted right from 0 to pi. So from 0 to, or pi halves would be right here. So I'm going from here, -3 to here. So my y's can range from 3 to -3, and I can have infinitely many x's in between those. Okay, so depending on what I want to choose from 3, or what I want to choose for y, anywhere between +3 and -3 of my y's, so that's what my y's are in, my y values. That's my y's are within there. So any number I can pick between 3 and -3, I could solve for an exact x, but this would be the general equation. All right, now like I said, the second part is actually solving inverse equations. So remember, arc sine is the same as sine inverse. So I'm solving inverse equations. So again, I'm trying to get the trig function by itself first. So divide by 2 or times by 1/2. Now I can go ahead and do the inverse, right? So the inverse would be, the inverse of an inverse is just the regular one. Switch the x and y. And now I can actually answer this equation, right? Sine of pi halves is 1. So x equals 1. And you can test that. You can plug that back in and test it. But that's good. I guess I can do it real quick. So plug in 1 back in to inverse sine of 1 or arc sine. Well, that's asking what is the angle when I get 1? When I plug in 1 as the side, well, that's pi halves. And then pi halves times this 2 would be pi, and pi equals pi. All right, so the other one, here we're working on this. So we want to solve, we have 2 inverses in here this time. Well, we only want 1. So here's where we're going to do a little substitution, right? Because it's easier if this side was just an x, right? That'd be really easy. And we can go ahead. So what if we just let it equal u? So we're just going to let this equal u. Then I can solve this inverse, solve for u. Just do the inverse, right? Switch them. So sine of u equals 1/2. Then it's best to just go ahead and draw this out. So draw a triangle. pick a u, or right triangle, pick a u. I'll let u be this corner. So sine would be opposite 1 over hypotenuse, right? So then I can do Pythagorean theorem, square that, subtract them. So 4 minus 1 is 3, square root it. So this side is square root 3, right? Use Pythagorean theorem. All right, so now I can go ahead and put u in here. So cosine inverse of x equals u. Now I can go ahead and solve this inverse by taking the inverse. So that'd just be cosine. The x and u switch places. So now I can solve this. Well, what is cosine u? Well, here's my u, right? My angle u. And cosine would be adjacent over hypotenuse. So that'd be root 3 over 2. And there's my x. And we can see that that's going to be true, right? What angle gives us 1/2? What angle gives us 1/2? That would be pi. That would be pi 6th. And what gives us a root 3 over 2? Exactly pi 6th, right? So there you go. So the alternate way of doing this, if that was too complicated to you with the substitutions and the u's and everything, you can actually solve this, right? Which I did, pi 6th. Sine inverse is pi 6th. So that would be cosine inverse of x equals pi 6th. And now I can just solve this inverse. And now I can answer this question, which I kind of did here, right, is root 3 over 2. So either way, you get the same answer. So maybe that second way is probably easier. Okay. So again, this one I have another two different inverse of sine and inverse of cosine. So again, I can't use both of them. And this one I can't solve, right? It's just a variable, inverse of a variable, inverse of a variable. So I want to get one of these by itself. Might as well just add the inverse cosine over. Cosine of x plus pi 6th, right? So here then at least I have one by itself, and now I can go ahead and take the inverse, right? So this and the answer is going to switch places, right? And the inverse of sine is, the inverse of inverse sine is just sine. And I might have shown you this maybe in another video or something. But remember the inverse is always looking for the angle, right? Okay, so that's always looking for the angle. So that's an angle, and this is an angle, and I'm adding them, right? So I have the sine, the sum. So remember how Sinbad does it? He goes with coset, the second angle. And then he says their sines are the same, and he makes his brother go with his sister. Okay, and this all equals x, right? Okay, so I just need to simplify it. All right, so we know what cosine of pi 6 is from our previous video, right? And we know what sine of pi 6 is from our previous example. So now we need to know what is sine of arc cosine. And remember, this is saying that we have an angle. This is asking for an angle. So it's saying if you want to draw a picture, this is a good one to draw a picture on. Again, a right angle. So pick an angle. We'll let this be our angle, right? And you can do theta or whatever you want. So this is saying that our angle, we have cosine, which is adjacent. So adjacent to that angle, x over 1, right? So then I can use Pythagorean theorem again. Solve for this side. So that's squaring those and subtracting them. So it's 1 minus x squared and then square root, right? Because this is not an angle. This is a side relationship because it's arc cosine. It's an inverse. So this x right here is not an angle. It is an answer, right? A side relationship. Okay, so now I can go ahead and find sine of this angle right here. So sine of that would be opposite square root of 1 minus x squared all over my hypotenuse, so 1. So this becomes square root of 1 minus x squared. and then we're going to times it by this and add, and then arc cosine of this. So you don't have to draw a triangle on this one, but here's my angle of reference, and I'm doing cosine, so that'd be adjacent, so x over hypotenuse. And here, we already know what this is because we already did it over there. But we're just asking for cosine. Well, cosine is just adjacent over hypotenuse, so it's the same thing, it's just x, right? So that's kind of easy. Remember, cosine, I might explain this in another video, but cosine of arc cosine of x is just always going to be x, and the vice versa. Arc cosine of cosine of x is always just x. All right, now let's go ahead and simplify this out. All right, so we have square root 1 minus x squared times root 3 over 2 plus 1/2 times x, so 1/2 x, and then we have equals x. Parenthesis right here. Okay. Okay, so now we can go ahead and simplify this. We can start solving this. So we can get our x's to one side first. So we can go ahead and, well, maybe just multiply everything by 2. Multiply this by 2, multiply this by 2, multiply this by 2, then we can get rid of those fractions, right? So this would be, why did I put a 3 there? Okay, because these would cancel, and then these would cancel. Okay, and then we can actually go ahead and square both sides. But before I square both sides, I want to make sure I only have 2 things on each side, or 1 thing on each side. So if I subtract x, I get my x's together. So this is just x equals square root of 1 minus x squared times root 3. Okay, and then I can square both sides. But remember, when you square both sides, you're going to introduce an extra answer, so you have to make sure to check here to make sure your solutions. So this is being multiplied, so I can distribute this squared here and that squared there. So this is just 3 times 1 minus x squared. So I can distribute that 3. And I could have really did that in the beginning because they're both square roots, so I could distribute the 3 to both of those and then squared it. But I would get this same thing. Then I can get my x squareds by themselves because it's a quadratic. So 4x squared equals 3, divide by 4, because I have no b, right? So I might as well just solve by square root. X squared equals 3 over 4, square root, top and bottom, so that'd be the square root of 3 over square root of 4, which is 2, and then plus or minus. So I need to check this. No. Equals x. So I need to check both of these. Okay, so I want to plug in. So I add arc sine of root 3 over 2 minus arc cosine root 3 over 2 equals pi sixth. Okay, so now we're just going to see and check and see if this is right. So what angle gives us root 3 over 2? Well, that's a pi thirds. What angle of cosine gives us a root 3 over 2? Well, that's pi sixth. If I subtract those, this would be 2 pi over 6. So 2 pi over 6 minus pi over 6 is pi sixth. So that does work out. The positive one does work out. The negative one doesn't, because I'm negative first. So for sine, I'm going to be below. So that's not going to work. Because if it's negative here, what gives me a negative root 3 over 2? Well, that's just a negative pi sixth. And where this one would stay the same. Negative root 3 over 2. That's all the way at 5 pi sixth. 5 pi sixth, right? Or this is actually negative pi thirds. And this one would be a negative 5 pi sixth. So that's not going to work out. So only the positive one's going to work. And maybe from the example, yeah. There you go. So just the positive one works out. So make sure you check, because whenever you square something on both sides, you're going to add an extra answer. Okay, so that is it for solving inverse trig functions. And so that's how you do it. So you want to isolate the one trig function that you're using, and then you want to use the definition of inverse, switching the x and y, switching my answer and what I'm taking the trig function of, right? And then solving it. If I actually do know what this answer is, then solve it, right? That was probably the easier way, is just solving what that is. Yeah, and that's basically kind of how you do it. You just take the inverse of it, and the inverse of an inverse is just the regular